Time for another one. Let's look at question 1. Quick check. Text-to-speech app needs to convert articles stored as text into natural-sounding speech for an audiobook feature. Which AWS AI service specializes in this text-to-speech conversion? Select one answer. Review the answer choices on screen. The correct answer is option D. Each AWS AI service has one specific job. Amazon Polly is an AWS service that uses advanced deep learning technologies to synthesize speech that sounds like a human voice. It can convert text input into speech in various languages and voices, making it suitable for creating audiobook features, voice prompts, and other speech-enabled applications. Hi guys, DAC Lessons here. Another 10-question session for you. This one's centered on SQS decoupling, cost allocation tags, and IAM least privilege. Same format as always. Question, countdown, answer, explanation. Pause anywhere you need to think. Enjoy. Track your correct answers. You will want your score for the wrap-up. Ready? Question 2. Compare what is asked to what is offered. Web App Secure Limited is launching a public web application in AWS. The architecture uses EC2 instances in a VPC, fronted by an elastic load balancer, ELB. DNS is managed by a third-party service. The company needs a solution to detect and protect against large-scale DDoS attacks. What is the recommended approach? Select one answer. Review the answer choices on screen. The correct answer is option C. WAF filters HTTP requests. Shield handles volumetric floods. AWS Shield Advanced provides enhanced protection against sophisticated and large-scale DDoS attacks for resources like elastic load balancers, Amazon CloudFront distributions, and Route 53 hosted zones. It offers features like advanced attack mitigation, 24/7 access to the AWS DDoS response team, DRT, and cost protection against DDoS-related usage spikes. This is the most robust solution for large-scale DDoS protection. Ready? Question 3. Every phrase counts. DataShare International, a survey company, has gathered years of data from U.S. areas, stored in a 3 terabyte and growing S3 bucket. They've started sharing this data with a European marketing firm that also uses S3 buckets. DataShare wants to keep its data transfer costs as low as possible. Which solution meets this requirement? Select one answer. Review the answer choices on screen. The correct answer is option B. The feature name is a hint that never lies. When Requester Pays is enabled on an S3 bucket, the requester, in this case the European marketing firm, pays for the data transfer out costs associated with accessing the data, rather than the bucket owner, DataShare International. This directly shifts the data transfer costs for downloads to the entity consuming the data, meeting DataShare's goal of minimizing their own transfer costs. Ready? Let's check question 4. Quick check. Elastic Transcoder Legacy. An application needs to convert user-uploaded video files into various formats suitable for playback on different devices, e.g. web, mobile. The company is looking for a managed AWS service to handle this video transcoding, while AWS Elemental Media Convert is the newer service, which older, simpler AWS transcoding service is also listed in the SAA-C03 exam guide for media services. Select one answer. Review the answer choices on screen. The correct answer is option D. 2 transcoding services. The exam still tests the older one. Amazon Elastic Transcoder is a media transcoding service in the cloud. It is designed to be a highly scalable, easy-to-use, and cost-effective way for developers and businesses to convert or transcode media files from their source format into versions that will play back on devices like smartphones, tablets, PCs, and smart TVs. While AWS Elemental Media Convert is the recommended service for most new video processing workloads due to its broader feature set and capabilities, Amazon Elastic Transcoder is still an in-scope service for the SAA-C03 exam. Keep your focus here, question 5. Picture the scenario first. Secure VPC network hosts EC2 instances in a private subnet containing highly sensitive data. Company policy dictates these EC2 instances can only access approved third-party software repositories on the internet via specific URLs for updates. All other internet traffic must be blocked. Which solution meets these requirements? Select one answer. Review the answer choices on screen. The correct answer is option A. NAT gateways route traffic but cannot inspect URLs. A NAT gateway allows outbound internet access but doesn't provide URL filtering. A proxy server deployed in a public subnet or accessible via a NAT gateway, if in a private subnet itself, can be configured with a whitelist of allowed URLs domains. EC2 instances in a private subnet would then be configured to route their internet traffic through this proxy. This allows fine-grained control over which external destinations can be accessed, meeting the requirement to allow only specific URLs while blocking other internet traffic. Managed services match to specific jobs, requester pays to shift egress costs, and a proxy where NAT cannot filter URLs. Keep your focus here, question 6. Start with what the user needs. Parallel Processing Co. is designing a cloud architecture for a new application. The process involves tasks that can run in parallel, with the system dynamically adding or removing stateless application nodes based on the number of jobs needing processing. Job items must be stored durably, and the architecture should be loosely coupled. Which design is most suitable? Select one answer. Review the answer choices on screen. The correct answer is option A. Queue depth as a scaling signal is a foundational AWS pattern. This design offers a robust, scalable, and decoupled architecture. Amazon SQS provides durable storage for job items. The Auto Scaling group, using an AMI containing the processor application, can dynamically adjust the number of EC2 instances, application nodes, based on the number of messages in the SQS queue depth. This ensures processing capacity scales efficiently with the job load. All right, question 7. The condition is doing work. RDS Disk Low uses an Amazon RDS MySQL DB instance for its application. The database is rapidly running low on allocated disk space. A solutions architect needs to increase the disk space available to the RDS instance without causing any downtime to the application. Which approach meets these requirements with the least amount of operational effort? Select one answer. Review the answer choices on screen. The correct answer is option A. Snapshot and restore works, but that is not least effort. Amazon RDS supports storage auto-scaling for most database engines and storage types. When storage auto-scaling is enabled, Amazon RDS automatically monitors the available free storage space. If the free storage drops below a certain threshold, RDS will automatically increase the allocated storage size without requiring manual intervention, and for many common storage modification scenarios, especially with newer instance types and engines, without causing downtime to the DB instance. This is the most operationally efficient and least disruptive method to handle dynamically growing storage needs. All right, question 8. Use elimination aggressively. New Dev Permissions Corp. is onboarding a deployment engineer who will use CloudFormation templates to create AWS resources. A solutions architect wants to grant this engineer permissions following the principle of least privilege. Which two actions are most appropriate? Choose 2. Review the answer choices on screen. The correct answers are option C and option E. The engineer's permissions and CloudFormations are separate concerns. Granting permissions via an IAM group with a carefully crafted least privilege IAM policy ensures the engineer only has access to necessary CloudFormation actions and related service permissions. E. For CloudFormation itself to create resources, it needs a service role with permissions to manage those resources. The deployment engineer's IAM user would need IAM, pass role permission for this service role, and permissions to manage CloudFormation stacks, e.g., CloudFormation create stack, CloudFormation update stack. This separates the engineer's permissions from the permissions CloudFormation uses, adhering to least privilege for both. Let's slow down on this one. There are 2 layers of permissions at play here, and they both matter. Imagine handing a contractor the keys to your building. You wouldn't give them a master key, just the doors they need. That's least privilege. Here, 2 things need permissions: the engineer and CloudFormation itself. The engineer joins an IAM group. That group has a custom policy, CloudFormation stack actions only. CloudFormation gets its own service role to create resources like EC2 instances or S3 buckets. The engineer just needs permission to hand that role off to CloudFormation. That's the key separation. The engineer can never directly create those resources. Only CloudFormation can, under its own scoped role. Option A is a master key. Option D buries credentials in template files. That's why C and E win. 2 layers, each scoped tightly. Okay, question 9. Identify the business need first. Monolith 2 Microco has a legacy data processing application running on EC2 instances. This application processes data sequentially, and its architecture is monolithic. The only way the company can scale the application to meet increased demand is by increasing the size of the EC2 instances, vertical scaling. The company's developers have decided to rewrite the application to adopt a microservices architecture, planning to deploy these microservices on Amazon Elastic Container Service, Amazon ECS. What communication mechanism should a solutions architect recommend for inter-service communication between these new microservices to promote loose coupling and scalability? Select one answer. Review the answer choices on screen. The correct answer is option C. SNS broadcast to all subscribers. SQS holds for one consumer. Amazon SQS, Simple Queue Service, provides a reliable, highly scalable, and fully managed message queuing service that is ideal for decoupling microservices and enabling asynchronous communication. Producer microservices can send messages, representing data to be processed or tasks to be performed, to an SQS queue without needing direct knowledge of the consumer microservices. Consumer microservices can then independently pull and process these messages from the queue. This pattern enhances scalability, as consumers can be scaled based on queue depth, improves resilience if a consumer fails, the message remains in the queue for another consumer or retry, and promotes loose coupling between the microservices. Here's why a message queue beats direct API calls, and what makes this pattern the go-to for microservices. Imagine you have 5 microservices. Service A needs to pass data to Service B. The easy instinct is a direct HTTP call, like a phone call. But if Service B is slow, Service A blocks. If B crashes, data is lost. Now picture 10,000 orders hitting at once. Every service gets slammed. SQS, Amazon's queuing service, acts as a buffer. Service A drops a message in the queue and moves on. Service B picks it up when ready. If B crashes, messages wait safely. You can scale B up by watching queue depth. That's the punchline. Loose coupling means services don't need to be up at the same time. That's why SQS wins over direct HTTP calls. Okay, question 10. Pick the complete answer. Product line cost tracking hosts multiple applications on AWS for its diverse product lines. These applications utilize a variety of compute resources, including Amazon EC2 instances and application load balancers. They operate in different AWS accounts, all consolidated under the same parent organization, in AWS organizations, and spanning multiple AWS regions. The teams responsible for each product line have consistently tagged every compute resource within their individual accounts using a standard product line IAD tag. The company now needs to generate more detailed cost reports for each distinct product line, leveraging the consolidated billing capabilities of AWS organizations. Which two steps are essential to achieve this granular cost visibility by product line using AWS cost management tools? Choose 2. Review the answer choices on screen. The correct answers are option B and option E. Selecting a tag and activate it are 2 different steps. B. To effectively use tags for cost allocation and detailed reporting within a consolidated billing environment provided by AWS organizations, the first step is to identify the specific user-defined tag key, in this case, product line ID that is being consistently applied across resources. This selection is typically performed within the AWS Billing and Cost Management console, accessible from the organization's management account. E. Once the relevant tag key has been selected, it must be activated as a cost allocation tag. Activating a tag instructs AWS to begin tracking costs associated with any resources that have this tag applied. After a processing period, usually up to 24 hours, this activated tag will become available as a filter and a grouping dimension in AWS cost management tools like AWS Cost Explorer. It will also be included as a column in the AWS Cost and Usage Report, CUR. This allows the company to generate detailed cost breakdowns by product line ID across the entire organization, providing the desired granular visibility. Let's slow down here. Activating a cost allocation tag is a 2-step move most people miss. Imagine you have 5 product lines and 200 EC2 instances scattered across 3 AWS accounts. At month end, all those costs land in one bill, no breakdown by product. Your team's already tagged everything with product line IID. That's step 1 done. Now you need to tell AWS to actually track costs by that tag. You sign into the management account. That's the root of your AWS organization, not a member account. Open billing and go to cost allocation tags. You find product line IID, select it, and hit activate. Within 24 hours, that tag shows up as a filter and grouping dimension in Cost Explorer. The exam trap. Tagging resources alone does nothing until you activate the tag in the management account. 3 takeaways from this session. First, SQS decouples producers and consumers. SNS broadcasts to all, choose based on fan-out need. Second, tag selection and activation in the management account are 2 required steps for cost allocation. Third, CloudFormation service roles let you grant stack creation rights without expanding the engineer's own IAM. 3 patterns run through the hardest questions here: SQS decouples, service roles scope permissions, and cost allocation tags need explicit activation. Lock those in. You are ready for whatever comes next. Before you head off, subscribing genuinely helps these reach more people prepping like you, so please do. Drop a comment with your score and any question you'd want explained deeper. Got an exam you want me to cover next? Name it in the comments. And if the pacing or visuals could be better for you, tell me. That steers the next batch.